Hi there. These are some examples of finding relative extrema, such as a relative maximum or a relative minimum. You also could potentially be asked to find increasing or decreasing intervals. You'd walk through these same processes or procedures. Okay, so when finding relative extrema, the type of question they could potentially ask would vary. You could be asked relative, or local is sometimes also what it's called. They might be very particular about it, find the relative maximum. Some cases they might even say find the x value of the relative maximum, really constraining your answer there. You know exactly what they're going to be looking for. But the procedures are going to be the same, no matter what the question happens to be, or most of the procedures are going to be the same. So you'd have, for example, y equals x cubed minus 6x squared plus 9x plus 1, and they'd ask you to find relative extrema or to find the intervals on which the function is increasing or decreasing. Again, the question could potentially change a little bit. But when you see that, you know you're going to have to start with finding your critical numbers. So we're going to take the first derivative, set it equal to 0. We get 3x squared minus 12x plus 9. And set that equal to 0. If this were a calculator question, again, I would take this, put it into my y equals, and calc my zeros. In this case, this does factor, so we're going to go ahead and factor out a 3. And that x squared minus 4x plus 3 factors one step further to x minus 3, x minus 1. And so I have two critical numbers at 3 and 1. Once you find those critical numbers, we're going to do an interval test here. We typically notate it by putting it on our number line. So we'll put 1 and 3, and then we're going to pick testing numbers in each of the intervals. Okay. So for me, I'm going to go ahead and test 0, 2, and 4. So those are in each of the intervals established by my critical numbers. Okay, when I'm testing them, I'm testing these numbers 0, 2, and 4 by plugging them into my y prime. Okay, when I plug in 0, I get a positive number, which because I get a positive number, I know that my function, my initial y function, is going to be increasing. Because, again, it makes sense, right? We just got a positive slope when we plugged 0 into y prime. My y prime was a positive number. I got a positive slope, which means if you think about what happens with a positive slope, it means my function is going to be going up. When I plug in 2, I get a negative slope, and so I know my function, my initial y, is going to be going down. When I plug in 4, I get a positive, and so I know my initial function is going to be increasing. Okay? And so with that, you have the tools you need to answer whatever question you might be asked. If they were asking for the increasing intervals, you'd say I was increasing on negative infinity to 1 and 3 to infinity. They asked for decreasing, you'd say you were decreasing on 1 to 3. If they asked you for just the x values of relative maximums and minimums, you could say, oh, I have a relative max at x equals 1, a relative min at x equals 3. In case they asked you for the entirety of the point, you'd say, well, relative max at 1, and then its y coordinate, excuse me, and then a relative min at 3 and its y coordinate. Well, to find their y coordinates, I'm going to take 1 and 3 and plug it into y, into my original function. And when I plug 1 in, I get 1 minus 6 plus 9 plus 1, which is 5. And when I plug in 3, I get 27 minus 54 plus 27 plus 1, which is 1. Okay, we'll do a couple more here. What if my function was y equals negative 2 over x squared minus 4? Okay, well, same thing. Let's start with our critical numbers. You could do quotient rule here. You also could rewrite this denominator as x squared minus 4 to the negative 1. And then you'd have a chain rule, power rule piece here. Personally, I'm probably going to opt for the quotient rule, just because with that d high, I know it's going to be 0 anyway, so it's going to go away. So we'd have low d high minus my high d low all over low squared. And again, like we talked about, the d high, this first term is going to go away, and so I'm going to be left with 4x over the quantity of x squared minus 4 all squared. Okay? So the question is, where are my critical numbers? So there's only one place where this fraction is going to equal 0, right? That one location is going to be at 0. What makes my numerator equal 0? But one thing you want to consider are those denominator equaling zeros. Reason why, in this particular case, because x squared minus 4, which is the denominator here, of course it's quantity squared, but x squared minus 4 is sort of the essential piece of what makes the denominator equal 0. Since that x squared minus 4 is also the denominator of my original function, I know that any zeros I get here are going to be discontinuities originally. So I'm not finding them because they're going to be relative maximums or relative minimums, right? They're discontinuities. But they do edge out your intervals. When we're talking about intervals of increasing or decreasing, they'd be ends of domain, and so you'd want to have factored that in. And if for some reason, say this had been a square root function here, y equals the square root of x squared minus 5, or something like that, you'd, in taking the derivative, end up with a denominator that you didn't originally start with. Well, you still want to make sure that those denominator zeros are on your number line, because again, they edge out your domain. And so they're going to be endpoints of intervals as we discuss our intervals of increasing, decreasing. So what makes this piece equal 0? Well, plus or minus 2. So then we're going to test them. -2, 0, and 2. Okay, relative extrema again. I'm plugging into my y prime. I'm going to be testing -3, -1, 1, and 3 by plugging into y prime up here. Okay, when I plug in -3, I get a negative, so I know my original function is going to go down. When I plug in -1, I get a negative again, so my function is still going down. When I plug in 1, I get a positive, so my original function will be going up. When I plug in 3, I get another positive, so my original function will still be going up. Okay, and with that, I have everything I need. I can discuss where I'm increasing. I'm increasing on 0 to 2 and 2 to infinity. I'm decreasing on negative infinity to -2 and -2 to 0. And then in this case, I have no relative maximums, but I do have a relative min at 0, and then its y value. And again, one more time, when I want to find the y coordinate, I take my x and I plug it into y up here to solve for y. And when I plug in 0 up there, I get 1/2. Okay, let's go ahead and do one more, and let's make this a calculator one here. So if you don't have your calculator out and you'd like to get it out, you can. Although even then, this one, you technically could solve without your calculator. You're going to need a quadratic formula, but in my mind we would make this a calculator one. Okay, so if we had y equals 5x cubed over 3 minus 3x squared over 2 minus 4x plus 1. Okay. So critical numbers first, take that derivative. You get 5x squared minus 3x minus 4. And the reason that I say we're going to use our calculator to do quadratic formula is because when you look to factor this one, there are no two numbers that multiply to -20 but add to -3. Right? So we aren't going to be able to factor, and do not add that 4 over. Right? We've talked about that several times. It breaks our zero multiple property, so we need to make sure that we leave this as -4. Don't add the 4 over and factor. Okay? To factor like we would like to do, it needs to equal 0. Okay? It doesn't factor those, so let's go ahead and make this a calculator. So you're going to take your calculator, you're going to go to your y equals, and you're going to plug in 5x squared minus 3x minus 4. plug in that function that I'm trying to figure out what its zeros are. And then for my window, because I don't really know what my zeros are, I want to make sure my window is big enough that I catch my zeros. I do know that I've got a quadratic here, and so if I'm looking at my graph, my picture, my window, and I don't see the full U, then I know I'm going to have to come back to this window and maybe make it a little bit bigger. But I usually find kind of going -5 to 5 or -10 to 10 is a good place to start. Okay, so if I were to graph that, hopefully I'll see my whole U, and sure enough I do. And I can see the two zeros that would result from the quadratic, one over here and one over here. Okay, and so I'm going to go ahead and do second calc, or F5, calc my zero. I'll calc this first zero first. I'm going to go left bound, right bound, yes. And I get that I have 1 0 here at x equals -0.6433981. And then my second zero, I'm going to repeat that process, second calc, or F5. Okay, left bound, right bound, and guess. And I get a second zero at 1.2433981. Okay, so let's go ahead and do our number line test. Again, we're plugging these into y prime. I'm going to take 2, 0, and -1 and plug it into y prime. When I plug in -1, I get a positive number, so I'm going to be, I know my original graph is going to be going up. When I plug in 0, I get a negative, so I know my original graph will go down. When I plug in 2, I get another positive, and so I know my graph will be going up. So I can answer the questions. I'm increasing on -infinity to -0.643. Excuse me, sorry. And 1.243 to infinity. I'm decreasing on -0.643 to 1.243. I have a relative max at -0.643, 2.509, and a relative min at 1.243, -3.089. And again, we find y values by taking our x values and plugging them into our original y, our original equation there. And there you go.